Yeah, hello everyone, myself Maruti, welcome you all to this math video session. In this video, I have taken a real application sum dealing with speed, distance and time. Okay, so let's coming to the train journey. In this question, we are discussing about two scenarios, two cases, how it goes on if the speed is this much, how it goes on if the speed is reduced or decreased or more, whatever it might be. So I will let you know how the sum works for you. A train travels a distance of 480 kilometers at a uniform speed. So before getting into the concept, let me tell you what's the meaning of uniform speed. Right, uniform speed means you can say generally the speed variations will be there. Right, speed variation, sometimes the speed may increase, sometimes the speed may decrease. By eliminating all those things, if the speed is going at the same level, something like 80 kilometers per hour, right, if the train is moving for a while, for a distance, if you take, we have a uniformity. If it is going with the same speed, we can call it as uniform speed. Okay, what is this? A train travels a distance of 480 kilometers at a uniform speed. He is talking about a distance. The distance is 480 kilometers and it is going on with a uniform speed. Okay, he has given distance and he is talking about the speed. And the one more thing what you have to remember is time. So how does the time related? We will discuss after completing the entire question. Okay, if the speed has been 8 kilometers less, so he has discussed regarding the first scenario, right? Distance of 480 moving with a uniform speed, that is case 1. Case 2, the same distance of 480 kilometers, but in the second case, speed has reduced. Right, reduce, that is, how can you say reduce? Less is the word. If the speed is reduced, right, again to travel the same distance, obviously we know if the speed is decreased, time of traveling will increase. Obvious that. Right, the same distance of 480, if we are able to reach in the first case in a time duration of 12 hours, example I'm saying, if the speed is reduced, obviously it may take something like 20 hours for us, means the time has increased. Why? Because speed has decreased. You have to remember the speed and the time relations are always inversely proportional. If you increase the speed, the time will decrease, or if the speed is reduced, time will increase. Obviously we all know that. So let us come back to the question in systematic step-by-step procedure in a diagrammatic representation. Let me go for that. A train travels a distance of 480 kilometers. To make you better understand, let me take 2 points. Let me call the first point as A and the second point as B. Okay, now the train journey is going on from A to B. Yes, this is the distance, right? Just now I said the distance is 480 kilometers. The distance is 480 kilometers, fine. Okay, the total distance is 480 kilometers. So now he is talking about two cases, right? Let me discuss with the case 1. Yes, let me discuss with the case 1. The distance he is talking about is something like 480 kilometers. This is case 1. Okay, obviously we have to talk about all the three concepts: speed, distance and time. Right, here the distance is 480 kilometers, he has already given. Right, now what might be the speed? As we didn't give the speed, as we are supposed to find the speed, let us assume that the speed is x kilometers per hour. Let the speed be this x kilometers per hour. This is the topic what he has given. But he is talking about one more case, which is nothing but case 2, right? So case 2, the situation, How does the situation vary? But what he says, the same distance we are traveling, distance is the same, 480 kilometers itself. Okay, the distance is 480 kilometers itself. But in the second case, what is saying, right. If the speed has been 8 kilometers less, 8 kilometers less means whatever the speed in the first case, in the second case, the speed has reduced by 8 kilometers per hour. So in the second case, speed equals whatever we might be having earlier, that is x, right? From that, he says less means you have to remember it's nothing but take away how much he is saying, it's nothing but 8. So the speed in the second case is nothing but x minus 8 kilometers per hour. This is what he's saying. Okay, so we got two scenarios, right? The first scenario, speed is equal to distance is 480. Okay, the speed we assumed it as x kilometers. In the second scenario, that same distance of 480 kilometers, speed has been reduced. So how much it has reduced? 8 kilometers per hour. So now I'm taking it as x minus 8 kilometers per hour. So, but the three variables are speed, distance and time. Right, we have already discussed about distance and speed. What is the thing which is missing here? It's nothing but the time. Right, to get to know how the speed, distance and time are related, let us come to our beautiful formula. What's that? Right, you have to remember, right, speed, distance and time, how they are related means we have to remember speed is equal to distance by time. Okay, this is the relation what we have. But in this question, right, we already know distance and we already know speed. What is the thing which is missing? The variable is t. That is what is missing. So the formula which we know, make it useful or make it make time as the subject here. Let's make time as the subject. If you make time as the subject, obviously we get time is equal to distance by speed. If you make means I have interchanged the speed and the time here. If you make time as the subject, time is equal to distance by speed. This is the relation what we are getting from the formula what we know. Okay, after getting the relation of the time, let's work on here. Right, in the case 1, what is the time of the journey or what is the time of the journey? Let us work on. So if you think about the time here, right, it is we are having distance by speed. What is the distance covered? The distance covered is 480 by what is the time we are taking? It's nothing but x kilometers. That is speed is x kilometers per hour. Right, now in the same way, if you think about what's the speed in this scenario, right, or what's the time taken, if you think about the time, again using the formula distance by speed, what is the distance here? It's nothing but 480 and the time taken is x minus 8 kilometers per hour. Right, if you think about the units there, if you think about the units, in the top the units are km, in the denominator kilometers per hour. You cancel out the kilometers and kilometers. Now obviously the time we got it as 480 by x minus 8 hours. Okay, so the part it goes to the numerator. So you have to remember, if you check it out, right, the units will become hours. So here we are having all the three variables. In the case 1, speed, distance and time. In the second case also, speed, distance and the time. Now, how they are related, how the time difference is there, how the relation between the case 1 and case 2 is given here. What he says, right, if the speed has been reduced, it would have taken 3 hours more to cover the same distance. What he says, when the speed is decreased, if the speed is decreased, this case, second case is taking 3 more hours than the case 1. You have to understand. That is the relation what he has given. When the speed is decreased, right, it is taking more time right? Obviously, that's what the relation what we have. If the speed is decreased, it takes more time. How much more time? It is taking 3 hours more than the time what it has taken in the first journey. Okay, now how the steps goes on and all, I will get back to you now. Yeah, so let's get back to the systematic approach of the sum, what I have explained you in a diagrammatic way. So what he has given, the distance of 480 kilometers, assumed from A to B. Okay, now let's go in a systematic word problem for 4 marks or whatever it might be. What he says in the first case, train, we have to talk about 3 things: speed, distance and the time. Okay, so let the speed of the train, let us take the speed of the train S1 is equal to x kilometers per hour. X kilometers per hour. Let's take the speed be x kilometers per hour. Okay, fine. Then what is the distance it has traveled? Distance travel. Let the distance traveled d1, or simply straight away d. Why? Because in both the cases distance is d only. Let the distance be 480 kilometers. No need to say length. It's simply distance travel. Okay, now we have taken the speed of the train. We took it as S1. Why? Because we are having 2 cases. In the first case, we assumed it as x kilometers per hour, and the distance traveled, obviously, in both the cases, 480 kilometers. Okay, now third criteria, that is nothing but the time. Right, so time taken, let us think about time 1, T1. Just now I said it's nothing but the distance by speed, right? Distance by speed. This is the relation what we have pointed out. Okay, now the T1 what we are considering, obviously the distance is nothing but 480 kilometers all divided by the speed x kilometers per hour. Okay, now if you check it out, the kilometers and the kilometers cancel, the denominator reciprocates, we can write it as 480 by x kilometers. Oh, sorry, it's nothing but the time. Kilometers, it's nothing but hours. It's nothing but, what is the time we are taking? It's nothing but 480 by x hours. Hours are left over. So this is the time what we got in the first case, right? Now let's go in the same way what he said. What he said, right? If the speed is 8 kilometers less, so the speed is reduced. Let's go. According to the problem, speed is reduced by 8 kilometers per hour. Speed 8 kilometers per hour. What does it mean? It says second speed means speed of the second journey equals to S2 equals to first speed minus 8 kilometers per hour. Whatever might be the speed, whatever might be the earlier one, we have to reduce it by 8. Means what? Right. What is the first speed we have taken? The speed S1 is nothing but x kilometers per hour minus how much we are taking? 8. Right. So the speed in the second case will be becoming x minus 8 kilometers per hour. So you have to remember this one. S2 means speed in the second case. It's becoming x minus 8 kilometers per hour. Now, if you check it out, again the relation T1 is equal to distance by speed. In the same way, T2 is also distance by speed. Okay, but you have to remember the distance is obviously, we have already taken the distance traveled equals the same distance. It's nothing but 480 kilometers. That is what it is already given to us. Right, the distance traveled is 480 kilometers itself. Now, time for the second journey in relation with the distance and speed is nothing but 480 kilometers by x minus 8 kilometers per hour. Obviously, it cancels. It's nothing but 480 by x minus 8 hours. This is the relations what we got. Now we got time 1. This is important for us now. The time 1 is important for us and time 2 is important for us. Now, so what is the relation he has given in between the times? Let's come back to that. So what he says, it is given that time for second journey is 3 hours more than the first journey. Right, what he says, the second journey, when the speed has reduced, it took 3 hours more. Right, if you convert in terms of symbols, so what he says, time for second journey is equal to, whatever it took for first journey, it took 3 hours more. Time for first journey plus 3. Why? Because you have to remember, more means plus. How much more? It is 3 hours more. The second journey, time for second journey equals time for first journey plus 3 hours. This is what the relation what we have. Okay, let's convert. So let's write it down. What is the time for the second journey? Right, what is the time taken for the second journey? I like to write it as T2 equals T1 plus 3. This is the beautiful relation what we got. Okay, now let's transpose time 1 here. What we'll get? T2 minus T1 equals 3 hours. This is what a beautiful relation what we got. I like to repeat this. Time for the second journey, that is T2, equals whatever the time taken for the first journey plus 3 hours. Why? Because he has given there 3 more hours, right? So it's nothing but plus 3. This is in terms of symbols we are taking and transpose. T2 minus T1 is equal to 3 hours. Now let's plug in the values what we got. So what's the T2 value what we got? It's nothing but 480 by x minus 8 minus what is the T1 what we got? It's nothing but 480 by x equals 3. What about the hours? Here also the units are hours, here also the units are hours, here also the units are hours. Just I am cancelling all the hours there. Now if you check it out, you can take it out, and one more thing as common, that is 480. If you take 480 as common, here we'll be getting 1 minus x minus 8 minus 1 by x equals 3. Now if you cancel this once, and this is nothing but 3 ones, right? 3 ones, 3 and 0. Are we able to 300? Oh yes, right. 3 ones, right? It's 6, right? And it's 0. So which you would plug it in, it's nothing but right. 160 x minus 8 minus 1 by x is equal to 10. That the relation what we got, right? We are getting. I'll get back to you. So let's get back to the calculation part now. It's a tricky calculation part, but we can make it the better. Right. So what we got? If you take 160 as common, right, we have cancelled and we got it as 160 inside in the bracket 1 by x minus 8 minus 1 by x minus 5. Now, whenever we have something in terms of numerator and denominator in between plus or minus, you have to remember we are supposed to take LCM. Okay, so what's the least common multiples? So x minus a and x, they both are not like terms, or we can't find the like terms for that. So the least common multiple, that is the LCM of that, just you write it out both of them in terms of product. Therefore, that is x into x minus 8. Now, how many times does it go? How many times? What are the factors? When we are checking x minus 8, close the x minus 8 and what is left over? X. Whichever we are checking, right, you close that and the leftover is nothing but the factor. Means x minus 8 should be multiplied with x to get x into x minus 8. That's what meaning is. Now, if you x minus 8, how many times does it go? X times. Now, x into 1, it's nothing but x there. Now, minus is there. Fine. Now, what should be multiplied to x to get x into x minus 8? I have given the logic for you. Whichever you are checking, close that and let me know the leftover. Here, what should be multiplied to x to get this entire stuff? We should multiply x with x minus 8. That x minus 8 multiply with 1. So that is x minus 8. Here, many students may forget to write the parenthesis there, which may mess up. So here it is in terms of the bracket or the parenthesis, we want x minus 8. Now take that minus inside. If you check it out, 160, if you take it inside, x, minus into minus is plus 8 by, let's write, it's nothing bad. So simply x into x minus 8 equals 1. Okay, now if you straight away, this is plus x and this is minus x, gets cancelled. Now, what is left over? It's 160 into 8 by x into x minus 8 equals 1. This is what we are getting now. Now, just you cross multiply that, whatever is there in the denominator, multiply to that. So, I'll be getting like 160 into 8 equals, this gets multiplied with 1, we get the same. That is x into x minus 8. Okay, now, so if you go for this, 8 zeros, it's 0, 8 6, 48, 8 ones, 8, it's 1, 2, 8, 0. Now you multiply this, right, applying the distributive, x squared minus 8x. Now bring all to one side so that we can convert in the form of a standard one. That is 0 equals x squared minus 8x minus 1280. Now if you convert in terms of a normal quadratic equation, it becomes x squared minus 8x minus 1280 equals 0. Now keep factorizing that. Whatever it might be, the quotient here is 1 and we are having 1280. What are the, let's do prime fact. Let's multiply 1 into 1280, we get 1280. Now let's prime factorize that. Let's take 2, 6, 4, 0, again 2, 3, 2, 0. Again, let's go with the 2, it's 1, 6, 0. Again go with the 2, it's 8, 0. Again go with the 2, it's 4, 0. So after getting the point 40 here, now just wait for a second and keep on checking out. 2 times 2 times 2 times 2 and 2. If you check it out, all those things, we'll be getting 32 as the product of that, and you take the 40 here. Okay, so 32 and 40. Why did I stop there? Means the middle term, the one which you have to split, is 8. The difference of both the numbers will be 8. Why? Because we are factorizing this one with the help of splitting the middle term. We are finding by splitting the middle term. Now if you check it out, 32x, right, plus 32x minus 40x equals minus 8x, what it's there in the middle term. So I like to, though I have taken the prime factorization, by keeping an idea that I need 8 in the middle, 8. The difference of any two terms, if the difference or the sum is 8, we can split it. Therefore, when I'm prime factorizing that, 2 to the power 5 is nothing but 32. 32 into 40 is nothing but 1280. But the difference of them will be minus 8x. Therefore, I'm using that. So let's simplify that one. X squared, right, plus 32x, right, minus 40x minus 1280 equals 0. Okay, now let's take the common here. Out of these two, I can take x as common. If you take x, it's x plus 32. Okay, now whatever we need to take common, of course, if we can plug it out, 1280 can be written as 40 into 32. That is what we got. 40 into 32 equals, right, this. If you multiply these two, you'll be getting 1280. We know that. Right, so 1280 has 40 and 32. Here we are also having 40 and 40. Take 40 as common. But please remember, whatever the sign we have at the beginning of that 40, it's the thing we have to take that also as common. Right, if you take minus and 40, what is left over? It's nothing but x, and minus means plus into minus. If you take minus out, we'll be having plus, and the leftover is 32 equals 0. Okay, now whatever is there in the bracket, x plus 32, you write once. And what is left over here, x minus 40, you write it down once. Now, applying the zero product property, Right, what's that? Right, AB equals 0 implies A equal to 0 or B equal to 0. By applying this formula, if the product of any two things is 0, either the first one is 0 or the second one is 0. By using that logic, let's go for that. X plus 32 equals 0 or, right, x minus 40 equals 0. This is what the value we got. Right, so now if you transpose for 32, you get minus 32 or x equals 40. Okay, now we got the value of x. What is this x? X is nothing but the speed of the train. Right, speed of the train. But you know, speed can't be negative. You have to remember that one. Speed can't be negative here. Speed can't be negative. So, obviously, which will become? This will become the right thing. So, speed of the train is 40 kilometers per hour. But please remember, until and unless we verify, we can't get the concept. Right. Yeah, so now as we have concluded that speed can't be negative, I have taken the other value of x, that is nothing but x is equal to 40. So we are concluding the speed of the train x equals 40 kilometers per hour. But until and unless you verify that, you can't say that you will be getting the perfection. So what's the relation what he has given? He said the difference between the two journeys is 3 kilometers. Or you can say that for second time, or when the speed is reduced to 8 kilometers per hour, it took 3 hours more. It took 3 hours more. That is what the relation means. T2 equals, this is what the relation has given. T2 equals T1 plus 3. This is what we have relation. But when we have transposed T to the other side, it became T2 minus T1 is equal to 3 hours. Let's plug in the value what we got, 40 kilometers per hour in that relation, and check it out whether it is 3 kilometers per hour or not. So let's plug in there. So let me go for the calculation here. 480 by x, how much you got? We are taking it as 40. Therefore, 40 minus 8 equals 480 by, it's minus, take away, so it's nothing but 40. Is it 3? We don't know. Okay, let's simplify that. 480 by 32 minus 480 by 40. Is it 3? We don't know. Let's check it out. So, if you cancel out, it's nothing but 12s. And if you check it out, it's nothing but 15. So, straight away, we know the relation there. For 15 hours minus 12 hours, we got it as 3. Is it correct? Yes, 3 hours equals 3 hours. So, LHS equals RHS. We can say it's verified. So until and unless we verify that, we can't conclude that, we can't justify our conclusion. So our conclusion is clear. that speed of the train is x kilometers per hour. Thank you. In this channel, I have been placing both math and science videos.